Now let us see how smart grid was evolved. So you can see in 1960 the electric grids of developed countries were very large and it were now matured and interconnected. So we can say that by 1960s we achieved the interconnected large power system network. Now by 1960s the topology of the grid was a result of strong economies of scale. So by 1960 we were able to know how to achieve economies of scale in case of the power system network. Now in late 1960s, the electric grid reached to majority of the population of the developed countries. So we can say that by 1960s, the late of 1960s, most of the uh, majority of the population in the developed countries was having access to the electricity. So because of that, what happened that during 1970 and 1990, the demand for electricity started growing. So the demand was more as compared to the generation. So that caused poor power quality, blackouts, frequent power cuts, brownouts. Because of that, the industry started demanding higher level of reliability. Now in late 2000s, the power system started implementing the peak load management. So because of that, the redundancy which was available in the grid increased, and as a result, the cost for the electricity company started increasing. Because of that, the tariff of the electricity also started increasing. Now in early 21st century, what happened? The improvement in electronic communication technology started happening. You can see that we started with the 2G communication, then we gone to 3G and 4G communications. So our electronic communication started improving. Because of that, the need for more sophisticated control on the power system network and the renewables, especially the wind power and solar power, started growing. Because now you can see from our previous lectures that the information technology as well as communication technology was maturing at this point of time. So the utilities and the vendors started demanding the better monitoring and control, because the infrastructure related to better monitoring and control was now available. Because of the integration of renewables, the power system network was now transforming from centralized grid topology to highly distributed topology, and we started uh, visualizing the bidirectional power flow in the power system network because of the integration of renewables. So because of the installation of solar and wind at the distribution network, sometimes the flow of power was going from distribution to transmission, for which the power system network was not designed. Then there was a growing concern over terrorist attack because of the increased use of information technology. So people demanded more robust energy grid with the implementation of cybersecurity aspect. Now, the biggest event which happened in the uh, history of smart grid was 2003 blackout. So in 2003, the US had the biggest blackout in its history, and that happened on 15th of August, which forced US to think about better monitoring and control of the power system network. And because of that, in 2007, they came up with the first official definition of smart grid, and this definition is given in the act which is called as Energy Independence and Security Act of 2007. We can basically abbreviate it as ESA 2007. Now let's understand what are the key aspects of this act and why the smart grid was so important. Now in ESA 2007 Act, the key points which were highlighted in this act are as follows. So this bill provides description with 10 characteristics that can be considered as a definition of a smart grid. It is the policy of the United States to support the modernization of nation's electricity transmission and distribution system to maintain a reliable and secure electricity infrastructure that can meet future demand growth and to achieve each of the following, which together characterize a smart grid. So this act is now talking about the term called smart grid. Now what are the key characteristics this act talks about? First is increased use of digital information and controls technology to improve reliability, security, efficiency of the electric grid. Because at this time you will see that the digital technology like your 3G communication was coming. So the utilities were interested to adopt those technologies for better monitoring and control, and then same has been highlighted in this act. Second is dynamic optimization of grid operations and resources with full cyber security, because when you deploy the information technology layer on the power system network, you need to have the system cyber secure to save the system from any external attack. So this act talks about the dynamic optimization of the power system network with full cyber security. Now third point is the deployment and integration of distributed energy resources and generation, including renewables. So the renewable integration is also an important component of this act. Then the development and incorporation of demand response, demand side resources and energy efficiency resources. So demand response means you will adjust your demand based on the various signals, mainly the pricing signals and the system loading conditions. So when the system is under highly stressed condition, the operators will increase the price of the electricity, which will force the customer to reduce its load. So in that way we can achieve the demand response. Now how we will do it? We will deploy the smart technologies such as real-time automated interactive technologies that optimize the physical operation of appliances and consumer devices, mainly for metering, communications concerning grid operations and status, and distribution automation. So you will utilize smart devices, especially the integration of smart appliances, so that the devices can sense the pricing signal and reduce or delay their operation for saving the price of the electricity. Now next point was the deployment and integration of advanced electricity storage and peak shaving technologies, including plug-in electric vehicles, hybrid vehicles and thermal energy storage system for air conditioning. So this adds stress upon the use of electricity storage for peak saving. That means whenever the peak loading condition happens, can we deploy the storage that can be in the form of static storage or the moving storage, that is electric vehicle. So electric vehicle can also be considered as an electric storage, and whenever the peak loading conditions happen, you can discharge electric vehicle to save the system. So this act highlights those aspects to address the problems which are there in the power system network. Now next is the provision to consumers of timely information and control options. So here you will see that the consumers are given more weightage. Why? Because now the consumer is no longer a consumer to consume the electricity, but he is also producing the electricity in the form of renewables. So now the consumer is not a consumer, but he is a prosumer, so who produce as well as consume the electricity. And to do so, he should have the timely information almost in real time available to him for better controls. Now next point was the development of standards for communication and interoperability of appliances and equipment connected to the grid, including infrastructure serving the grid. So this act also talks about the communication as well as interoperability aspect of the system. The 10th point which was there in the act was identification and lowering of unreasonable or unnecessary barriers to adoption of smart grid technologies, practices and services. That means we have to make the all stakeholders aware about the smart grid technologies, including utility personals, vendors, even end consumers, so that the concept of a smart grid can be implemented efficiently.